this assessment, we'll draw the molecular orbital picture of trans-2-butene. We'll start by recognizing that in trans-2-butene, the hybridization of the carbons are as follows. The two terminal methyl groups are sp3 hybridized, meaning that these two carbons will form their bonds using 4 sp3 hybridized orbitals, and the central two carbons here and here are both sp2 hybridized. And so 3 of the bonds to those carbons will use sp2 hybridized orbitals, and this pi bond will be formed using the leftover p orbitals at each of those carbons. With that in mind, we're ready to start drawing. Let's draw the sigma bonded framework first. We'll start by connecting all of the carbons using sp2 or sp3 hybridized orbitals respectively to make the 3 carbon-carbon sigma bonds. We can go ahead and add in, let's work with the terminal methyl groups first. Let's draw in the hydrogens, making sure to show the tetrahedral shape. So we'll have 1 orbital coming out of the plane, 1 going back into the plane, and we'll do the same thing on the other side. 1 coming forward and 1 going back. So we want to make sure that that tetrahedral shape is shown. The 2 central carbons here, part of the alkene, each have a hydrogen, so we can connect those using an sp2 hybridized orbital in both cases, making sure that we show that these carbons are all in the plane of the page. All that remains is to show the pi bond using the overlapping p orbitals, and because we've kept the majority of this structure in the xy plane, that tells us that it's the pz orbitals that are left over. And so we need to draw these so that we see, let me put it here, we need to draw these so that we see that the pi bond is formed above and below. Kind of squeeze these in, make sure they look like they're aligned, and then connect the lobes of the individual p orbitals to make the pi bond. Note that this is not the pi bond and this is not the pi bond, but those together represent the pi bond. So the pi bond is formed above and below the plane of the sigma bonded framework. This is the molecular orbital picture of trans-butene.